A very good morning to one and all. Myself, Professor Chetan Gupta, CSE Department, SIRT, the SAGE Group Bhopal. Today, we will discuss about a subject that is computer network. The subject code is CS602. And in today's lecture, we will discuss about a topic that is a token bus. The technical name of the token bus is the IEEE 802.4. Okay, moving on next slide. First, what is token bus? Basically, token bus is a popular standard for the token passing lanes. In a token bus LAN, the physical medium is a bus or a tree, and a logical ring is created using the coaxial cable. That means if we want to discuss about the token bus, first we need to discuss why we use token bus. So whenever a multiple host or a multiple user try to send the data at the same time, the problem is that there may be a chances of collision, because whenever two or more station try to send that data at the same time, then collision may happen. And if the collision is happen, then our data is lost, or data may be an inappropriate data. Whenever that data received by the receiver, then data may have damaged copy. So here we are going to discuss about a technique how we can avoid that collision. Means we want that if station want to send the data, so they will send the data one by one. So what is the procedure behind that? So another method is the token bus. So basically token bus is a standard in which we have to passes the token in the logical ring. Basically if we want to create a token bus, so what we do in a token bus, we will connect all the computer in the form of a logical ring that is created using the coaxial cable. The token is passed from one user to another in a sequence in a clockwise direction or an anti-clockwise direction. Each station know the address of the station to its left and right. Means each and every station knows the address to its neighbor node. So whenever a data is received by a particular station, if that is not a destination, then that token must be passed through the next node. Means the token is passes in that logical ring again and again until that data packet does not reach to its exact destination. In this, a station can transmit only data when it has a token. The working of token bus is somewhat is similar to the concept of token ring. Here in this diagram, what we have seen that there are five different stations: station 1, station 2, station 3, station 4, and station 5. And they are sending the data in anti-clockwise direction, or we can also send the data in clockwise direction. So whenever any station want to transmit any data, what he need to did, he first claim a token. Whenever any station want to send a data, first it need to claim a token. Means that token must be removed from that logical ring, and instead of that token we will passes the data packet along that logical ring. We have clearly seen in the diagram that all the stations are connected in the bus topology form. Means there is a backbone cable and all the station are connected with the help of drop line or with the help of connector. But we have also seen that all are connected in the form of logical ring. Means a token is passes from station 1 to station 2, then station 2 to station 4, then station 4 to station 5, then station 5 to station 3. So the concept behind is that whenever any station want to transmit the data, first it remove the token from the token ring, and what it can did, it put the data inside that logical ring, and data is passes from one station to another station, and data is moved from one station to another station again and again until it does not reach to the exact location. Whenever any data packet reach to its exact destination, what that station did, it basically removed that data packet, gathered that data, and generate a new token, and again put that new token in the logical ring. That means whenever any station want to send the data, it claim a token, and when any station receive the data, so what it can remove, it can remove that data packet and put the new tokens. So the concept behind the token is that the station which have the token, it can only that station can send the data in the token bus. Now, if we talk about how we can understand the concept of that token bus, so what we have seen in the diagram, basically this is orange line is basically a backbone cable or a backbone link in which all the stations are connected with the help of drop cable, and all these stations are connected in the form of logical ring. We have also seen there is a mention that the direction of token passing, there are different kind of station that are connected to physically as a bus topology or in the bus form, but logically they are connected in the ring form. So what is token? A token is a small message that circulates among the station of a computer, providing permission to the station for the transmission. If a station has the data to transmit, when it receives a token, it sends the data and then passes the token to the next station. This process is continue again and again. Otherwise, it simply passes the token to the next station. Means if any station does not have a data to send, it just passes the token, and if the second station also do not have any data for sending, then it again passes the token to the next station. And if the third station want to send the data, they have some data to send, so what it can do, it remove that token, and instead of that token it put the data in that logical ring. Physically it is a token bus, but logically it is a token ring. Basically this is a frame format of token bus. There are different kind of blocks is there, for example preamble, start delimiter, frame control, destination address, source address, payload, checksum, and delimiters. Payload have a variable length, and each block have a different size, like preamble have 1 byte, start delimiter have 1 byte. And in the next slide, we have discussed what are the important fields of that particular frame format of token bus. First, if we want to understand what is preamble, so basically it is a 1 byte field used for synchronization. If we talk about start delimiter, so it is also a 1 byte field that mark the beginning of the frame, that is a start delimiter. Then the third one is a frame control, it again 1 byte long, that specify whether this is a data frame or a control frame. So that field contain the frame control information. The next one is the destination address. Basically destination address is 2 to 6 byte long, and it basically specify the address of a destination. Means whenever we want to send any data packet to any destination, we put the address in this destination address field. The next field is the source address. Source address basically a 2 to 6 byte long, that specify the address of source station. Source station means the station that want to send the data to a particular destination. So source address, we can put the source address field, and the destination address we can put into the destination address field. Now the next field is the payload, which is a variable length field that carried the data from the network layer. Means payload, what it can basically did, it basically add the data that received from the network layer. The next field is checksum, that is basically 4 byte long. in which a frame check sequence for error detection. Means checksum field, why we insert that field? Basically it is used for error detection or any checking sequence. Now the last field is the AND delimiter. AND delimiter is basically 1 byte long that makes the or marks the end of a frame. Means start delimiter indicate the beginning of a frame and end delimiter indicate the ending of a frame. And different field like source address and destination address, they contain the source address and the destination address, that which one is a sending device, which one is a receiving device. Payload basically contain the data. And frame control either contain the information that is that particular frame is a data frame or a control frame. We have to go back in the slide. So this is basically a frame format of a token bus. So in today's lecture, we will discuss about token bus and why we need to understand the token bus, or why the existence of token bus is implemented, because we do not want at any point of time our data packet will collide. Means if two or more stations try to occupy the channel at the same time or try to send the data at the same time, so there may be a chances that a particular station send the data and another station also send the data. So there may be a chances that the start of any data packet will collide with end of any data packet. So in this particular situation, the data packet will collide and the data of both the frame will be damaged or may contain some kind of error. So to control this multiple transmission at the same time, we introduce the concept of this token bus, in which all the stations are connected in the form of logical ring. And if any station want to send the data, it basically claim the token, put the data in the ring, and that data passes from station to another station and from that station to another station until it does not reach to its exact destination. Whenever the data packet is reached to its exact destination, what it that particular site did, it removed that particular data packet and put a new token in the ring, so that again we can give the chance to another computer to claim that new one token. So this is the process. So we can say that the concept of token bus in which computer are connected, we can avoid the problem of that collision, because if the station does not have any token, it does not send the data. Means if any station want to send the data, so it first claim the token. So in today's lecture, we will discuss about how we can avoid the collision while sending the data. So token bus is the concept. So in our next lecture, we will see the concept of a token ring, which is also related with the token bus. So thank you so much.